Hi, I'm Jim. This time I'll be discussing the basic operations involving functions. Like polynomials, we can perform operations on functions. Functions can be added, subtracted, multiplied, and divided. We also have other special operations on functions. We also have what we call the composition of functions. In addition, we can also determine the inverse of some functions. Now, if f of x and g of x are two functions, then for all x in the domain of both functions, the sum, difference, product, and quotient are defined as follows. The sum f plus g of x is equal to f of x plus g of x. The difference f minus g of x is equal to f of x minus g of x. And the product f times g of x is equal to f of x times g of x, while the quotient f over g of x is equal to f of x divided by g of x, where g of x should not be equal to 0. Since functions are usually expressed in terms of polynomials and or algebraic expressions in general, you need to recall the rules and principles in the operations of polynomials and or algebraic expressions. You also need to review the laws of exponents, even the properties of real numbers, like when we operate on integers, fractions, etc. Now, I'll be presenting some examples. Suppose we have these two functions, f and g, defined as follows. F of x is equal to x squared minus 1 and g of x is equal to 2x plus 4. We'll find a, the sum of these two functions, b, the difference between these two functions, c, the product of the two functions, and d, the quotient f divided by g of x. Alright, first we'll solve for the sum f plus g of x, okay? So again, this is just the sum of the two functions f of x plus g of x, okay? So we'll plug in here these expressions for these two functions, okay? So this will now become x squared minus 1 plus the second expression 2x plus 4. Then we'll just collect like terms. So this is just very similar, guys, to addition of polynomials. No? This is now equal to x squared plus 2x. Okay. Then collecting like terms here, negative 1 and positive 4, of course, would give us the sum of positive 3 there. So this is now the sum of the two functions denoted by f plus g of x, right? Now, for the difference f minus g of x, of course, this will just be equal to f of x minus g of x, right? So, this will now be x squared minus 1 minus the quantity 2x plus 4, okay? Now, I want to emphasize here that, again, when we are subtracting this whole quantity from this one, we should be careful with this negative sign, okay? We should apply this negative sign to each of the terms inside. We, again, are reminded to make use of these grouping symbols, okay? So, this will now become x squared minus 1 minus 2x minus 4. And again, collecting like terms and arranging to standard form, this will now be x squared minus 2x minus 5, right? Now, for the product, f times g of x, this will just be the product of the two factors f of x times g g of x. These factors, of course, are the functions. So this will be then the quantity x squared minus 1 times the second expression, which will become the second quantity here, that second expression for g of x, right? So this will now become, okay, so here we will be multiplying these two binomials, right? Now to do so, we multiply each of the terms of the first polynomial, which is a binomial here, by each of the terms of the second one. So this will become x squared times 2x is 2x cubed, and x squared times positive 4 is 4x squared. Okay, then also we'll get the second term, negative 1, and multiply by each of the terms of the second one to get what? Minus 2x minus 4, right? And to simplify, well, this is already in its simplest form, right? And arrays also in standard form. So this is now the product. Okay, for the quotient f over g of x, this is just the quotient of the two functions f of x divided by g of x, right? Of course, we always say that g of x, the denominator, must not be equal to 0. Now, substituting these expressions for f of x and g of x respectively, we'll be getting what? F of x is x squared minus 1, so we'll have it here all over g of x, which is 2x plus 4, right? Now, trying to simplify, we don't see any common factors between the numerator and the denominator, because when you find the complete factors of the numerator, they will be x plus 1, no? This being difference between two squares, so the factors are two binomials, x plus 1 times x minus 1. Okay, with the denominator, although there's a common factor of 2, and the second factor will be x plus 2 when that common factor is being extracted. As you can see here, we don't have any common factor between the numerator and the denominator. Thereby, this must be the final answer, no? Which is the quotient already in its simplest form. Let's have some other examples. This time we'll incorporate the procedure of evaluating functions. Suppose we have these two functions, f and g, given as follows. F of x is equal to 3x plus 2, and g of x is equal to x squared minus 4. We'll find the sum f plus g of 2, and this second one, f, which is a quotient, f over g of 3, right? Okay, so here, first we'll find f plus g of 2, okay? Well, there are two methods to do this one. Okay, we can have first the sum of the functions f of x and g of x, okay? After some simplifications, that will then be the time you will be evaluating this sum at x equals 2, okay? Or another procedure is, we can first evaluate the functions f of x and g of x separately at x equals 2, then combine them by adding, okay, to get the sum. That is, you can have f of 2, then add to g of 2, right? Now, let's show first this second procedure. Okay, so here f of 2 is of course equal to, just substitute this value of x, which is equal to 2, into this expression for f of x. We'll then get 3 times 2 plus 2, right? This is equal to 3 times 2 is 6 plus 2. This will be equal to 8. Similarly, for g of 2, we'll also substitute this value of x, which is equal to 2, into this expression for g of x, for us to get 2 squared minus 4. This will be 4 minus 4 equals 0. Thereby, this sum will now become, okay, 8 plus 0. This will be equal to 8. We'll show that we'll also get the value of 8 when we'll first find the sum f of x plus g of x. After some simplification, we'll be evaluating that sum, right, at x equals 2, right? So we'll now have it as the expression for f of x given by this. We'll now copy it as 3x plus 2. Then that of g of x, which is x squared minus 4, right? Simplifying, this will now be x squared plus 3x positive 2 minus 4 will be what? Negative 2, right? Then we'll evaluate this at x equals 2, okay? To become 2 squared plus 3 times 2 minus 2, okay? And this will be 4 plus 6 minus 2, which is of course equal to 8. So if you can remember, this is the same value when we tried to evaluate this one, okay, by considering those values when we evaluated the functions f and g separately. That is, when we had f of 2 added to g of 2, okay, which was that first method that we had a while back. Okay, now we'll have letter B, which is f over g of 3, okay? This will be equal to, f is given by this expression, while g is given by the second one. So this will now be the quotient 3x plus 2 all over x squared minus 4, right? Then substituting this value of x, which is equal to 3, into this variable x, then we'll have what? This will now be equal to 3 times 3 plus 2, which is equal to 3 squared minus 4, which will give us 27 plus 2 all over 9 minus 4. Simplifying further, this will now be 29 all over 5. Okay, so this is now f divided by g of 3. Alright, in my next video, I'll be discussing about composition of functions and inverse of functions. Thanks for watching.